I'm Roland Minton. These are some of my favorite math stories. In this episode, mathematics is formal. We'll see how a lack of attention to details can lead us to the conclusion that adding up all of the positive integers produces a negative fraction, negative 1/12. We use the word formal for this misguided derivation because the form of the calculations looks correct, but the meaning of the calculations is ignored. The basic question is, what do you get if you add up all the positive integers? 1 plus 2 plus 3 plus 4, and so on. Clearly, your sum continues to grow, so a good answer is infinity. But if it did equal some real number, what would it be? We'll start with a different calculation, then watch everything go completely wrong. Give the name S to the sum 1 minus 1 plus 1 minus 1 plus 1 minus 1, and so on. One way to look at this is to say that S is a geometric series starting with C equals 1 and with common factor R equals negative 1. Geometric series sum to C over 1 minus R, which is 1 over 1 minus minus 1, or 1/2. S equals 1/2 kind of makes sense, as the average of the first n terms within even is 0, and within odd is 1. But if I'm being fussy, I would say that the geometric series is only supposed to be used if R is between negative 1 and plus 1, not including either endpoint. So R equals negative 1 is not supposed to work. But maybe that's just a fussy mathematician speaking. Next we'll look at T, defined to be 1 minus 2 plus 3 minus 4 plus 5 minus 6, and so on. We will add T to both sides of the equation and offset the numbers a little bit. Add up pairs of numbers on the right side as they are stacked. So on the left, T plus T is 2T. Got our 1 on the right. Minus 2 plus 1 is negative 1. 3 minus 2 is plus 1. Minus 4 plus 3 is negative 1. And so on. Plus 1 minus 1, etc. Well, that's what we called S, and we decided that was equal to 1/2. Now, if 2T equals 1/2, T equals 1/4. I'm not sure why this one makes any sense. But let's plow ahead formally and look at x, 1 plus 2 plus 3 plus 4 plus 5, and so on. So subtract t from both sides. We'll just write it as t on the left and then subtract 1 minus 2 plus 3 and so on the right. Got x minus t on the left. On the right, every other term cancels. 1 minus 1 is gone. 2 minus minus 2 is 4. The 3's cancel, but the 4's add together to 8. 5's cancel, 6's add together, and so on. So we've got 4 plus 8 plus 12 plus 16. All of these have a factor of 4 in them. We can factor that out. So that's 4 times the quantity 1 plus 2 plus 3 plus 4, and so on. Well, that's what we're calling x. So looking from far left to right, we've got x minus t equals 4x. Subtract x from both sides, we've got minus t equals 3x. So x is negative t over 3. Finally, we decided that t was 1/4, plug that in, and we've got x equals negative 1/12. So we now have 1 plus 2 plus 3 plus 4 plus 5 and so on equals negative 1/12. Well, here's at least two questions. How can you add integers together and get a fraction? How can you add positive numbers together and get a negative number? None of this makes sense. So what went wrong? Well, we did cheat a little on that first infinite series. But the main issue is that we treated an infinite sum like a sum of two numbers. When adding 2 or any finite set of numbers, you can switch the order and nothing changes. 2 plus 3 is the same as 3 plus 2, and so on. This is not legal for infinite sums. So our trick of adding t and t is not legal. Well, why is it not legal? To see why, take the sum s defined as we did 1 minus 1 plus 1 minus 1 and so on, and rearrange some of the ones. Let's swap the second and third, fourth and fifth, and so on to put two 1's in front. Now we have s equals 1 plus 1 minus 1 plus 1 and so on. But after that first 1, we've got 1 minus 1 plus 1 minus 1, that's s. So our equation says that s equals 1 plus s. But that's impossible. The other issue in our weird calculation is assuming that s, or t, or x exists in the first place. The only reasonable thing to say about x equals 1 plus 2 plus 3 and so on is that x goes to infinity. Infinity is not a real number. Among other complications, infinity plus 1 is infinity. A way to view what we did say is if s is a number, it should equal 1/2. But this does not guarantee that s is a number, and s equals 1 plus s puts that idea to rest. Let's say a little more about switching the order of addition in an infinite sum, usually called in calculus an infinite series. There are times you can do this. If all the terms being added are positive and the sum exists, is a finite number, then you can rearrange terms. If you change all of the negative signs in s or t into plus signs, the sum clearly goes to infinity, so our little trick of adding offset items from two versions of t is not allowed. That theory stuff actually is important. There's an interesting addendum to this calculation. In many cases, formal calculations that mathematicians want to suppress leads to correct answers, or at least useful answers. In this case, our result interpreted properly leads to an important conclusion in the physics field of bosonic string theory. Further, the computation of the Casimir force for a scalar field in one dimension, physics, depends on this calculation. Now, it's not fair to say that even when math calculations are wrong, they're right. But it is important for mathematicians and users of mathematics to be clear about their assumptions and not label calculations as correct or useless outside of their intended contexts.